Hey everyone, and welcome. Today, we are diving into a principle that can totally change the way you build software, the Dependency Inversion Principle. This is the D in solid, and trust me, it's a game changer for managing how different parts of your code talk to each other. It helps you build stuff that's way more robust and easier to maintain. So let's get right into it.
You know that feeling, right? You need to make just one tiny change, maybe switch out a database or add a new way to send a notification, and all of a sudden your whole application just breaks. It's super frustrating and it happens all the time. So what's really going on here?
Well, the real problem here is something we call tight coupling. Imagine all the different parts of your code. Your main logic, your database connections, your external services are all tangled up in this one giant messy knot. When they're that connected, changing one little piece means you have to go and change everything else it's tied to. It's a recipe for disaster.
But here's the cool part. The solution is something you use literally every single day, and you probably don't even think about it. We're going to use a really simple analogy to get the hang of this before we even touch a single line of code.
Okay, so picture this. You're plugging in your laptop. Your laptop, that's what we'd call the high-level module. It's the thing trying to get important work done. Then you've got the power plant, which is the low-level detail, this huge, complex system that actually makes the electricity. Now, does your laptop care if that power comes from a coal plant or solar panels or nuclear reactor? Of course not. It only cares about one thing, that standard, predictable power outlet on the wall. And that outlet, that's our abstraction.
And that right there is the whole idea in a nutshell. See, your device depends on that standard, super stable outlet, the abstraction, not on the messy, complicated, and potentially changing power plant. This simple standard completely separates your device from the power source.
Okay, so let's take that exact same idea and bring it into our code. Instead of having our important business logic directly plugged into the nitty-gritty details like a specific database, we're going to flip that dependency on its head. We're going to invert it.
So here's the official rule, the Dependency Inversion Principle, or DIP. Rule number 1. Your important stuff, your main business logic, what we call high-level modules, shouldn't be directly connected to the details, the low-level modules. And rule number 2 is the key. Both of them should depend on abstractions. What's an abstraction? Just think of it like a contract or a blueprint, an interface in code. It says what needs to be done, but it doesn't care how it gets done.
Let's actually see what this looks like. Over on the left, we've got the bad design. See how the high-level logic is pointing directly to a MySQL database? They are stuck together. No escape. But now, look at the right side, the good design. We've put this iRepository interface right in the middle. It's like a universal adapter. Our high-level logic only cares about the interface, and our MySQL database simply promises to follow the rules of that interface. They don't depend on each other anymore. They both depend on that shared contract in the middle.
So what's the big deal with that bad design? Well, first, it's rigid. You want to switch from MySQL to something else? Good luck. You have to rip open your core business logic to make that happen. It's also super fragile, because a small change in the database code could create a domino effect and break your application. And oh man, it's a nightmare to test. You can't easily swap out the real database for a fake one to run your unit tests.
Okay, so you're probably wondering, how does the main logic get the actual database if it doesn't know about it? Great question. That's where this other cool technique called dependency injection comes into play. Think of it as the magic that plugs in the real MySQL database into the outlet, our interface, when the application starts up. The business logic never has to create it itself.
All right, time for a quick scenario. Let's test this out. A new developer joins your team and they say, hey, every time I try to add a new payment gateway like Stripe, I have to go in and change the main checkout service class. What does that tell you?
Yup, you nailed it. That is a textbook violation of the Dependency Inversion Principle. The checkout service is a high-level module, and it's tightly coupled to a specific payment method. It should be depending on something generic, like an iPayment gateway interface.
Let's move from theory to a real-world example that you've probably built 100 times, a notification system. This is a perfect place to see DIP in action.
So the old way, without DIP, your notification service probably knows everything about sending an email. It's hard-coded to talk directly to an email sender class. Sounds simple, right? But then, product comes along and says, we need SMS. So what do? You have to crack open the notification service and add a bunch of new logic. Then they ask for push notifications, and you have to change it all over again. The class is never stable.
But check out the solution with DIP. Now, the notification service only knows about a generic iMessage sender interface. The email sender class implements that interface. So when you need to add SMS, you just create a brand new SMS sender class that also implements that interface. The notification service itself, it never changes, not a single line. It's open for new features, but it's closed off from being modified. That's a huge win.
Okay, so we've gone through the analogy, the rules, the examples, but what's the real payoff here? Why should this actually matter to you when you're sitting down to write code?
Oh, the benefits are absolutely massive. First up, testability goes through the roof. You can just swap in fake versions of your dependencies for unit tests. It's so easy. Your code also gets super modular. The different pieces are independent and you can reuse them elsewhere. It becomes incredibly flexible, letting you adapt to changes without major surgery on your codebase. And finally, you just get a cleaner architecture where it's obvious how everything fits together.
So if you're going to remember just one thing from all of this, let it be this mantra. Somutadail, soyutabam laol. That translates to depend on abstractions, not on concretions. Depend on the power outlet, not the specific power plant. This is the absolute heart of the dependency inversion principle.
And that's pretty much a wrap. So the next time you're in your code and you find yourself about to type new mysqldatabase.com or new Stripe client right inside your business logic, just pause for a second and ask yourself, where can I build the next power outlet in my code to make it more flexible, more testable, and ready for whatever comes next?